everybody, welcome to this new Pix4D webinar. Today's topic is aerial, oblique and ground, how to merge these different datasets. My name is Oliver Kung, and I hope I welcome everybody here and we'll have a good time about explaining in detail a little bit how to merge these different datasets together. As usual, you can type questions in the chat box on the right during the whole webinar. We have the support team that's going to answer in live your questions, and I'm also going to read some of them during the webinar and also at the end to complete the discussion. All right, so let's start directly into this webinar. The first thing I'll introduce is a little bit of theory between what's so different between Nadir pictures and oblique or ground imagery. So when I'm talking about Nadir, it's really images which are taken from the sky, looking downwards the ground, and doing it in a perfectly perpendicular angle with respect to the surface that you're trying to take pictures. So more or less, when you have a fixed wing UAV, for instance, you're doing mostly oblique, you're doing mostly Nadir imagery. And an example of that would be, for example, the guided tour datasets, which comes together with Pix4D Mapper, where you have images taken most of the time in a grid fashion from the top, with our recommended set values are usually something like 75% overlap from the front and something like 60% overlap from the side. There's a whole webinar dedicated to how to optimize your flight plans for Nadir imagery. So today I'm more going to talk a little bit more about the other case, which is oblique imagery, which is when you have your picture, which is not exactly looking straight down, but from the side and actually from any position. And the general use cases when this happens is when usually you have a copter UAV, so not a fixed wing, but more a copter, which is looking with taking the images with a 45-degree angle to the ground. And the other use case, which often happens, is when you do it from the ground. So you're holding the camera and you're walking in the street, for example. So now the big question in this everything which is oblique is, what does the overlap mean? In the Nadir world, it was very easy to define overlap because it's what's in front of the image is what on the side of the image. But what was the goal of this overlap? The biggest goal was really to ensure that there is a large amount of matches, of key point matches between every images, and that these key points that we detect and that we match are as well placed on the image as possible. Here, on this example, you can see that every single orange cross is a key point that has been matched. And the fact that you have so many matches is due to the fact that you have a lot of overlap. And in addition, the fact that they are well placed all over the image is essentially due because you have enough image from on the right, left, front, and back of this other image. So it's very easy to compare a lot of features from the different images. However, in oblique, things are more complicated. As a very, very little example, this is an example taken by my cell phone. 3 pictures of somebody from different angles. And the big difference with respect to the imagery that we just saw before, the one which is aerial looking down to the ground, I would say that the biggest difference is really that you have much bigger difference of variation of depth in a single image. So if I would take this set of a few images of myself with a cell phone and put it in Pix4D Mapper, I would obtain such a result. So the software would very likely be able to position the images and to give somehow a point cloud 3D model. However, what's very, very interesting is clicking on one of this image to see where does the key point, where are they located in the image. And this is what I did in this screenshot. On the right, you can see one of the 3 pictures I showed before, and you can see that the key points are mostly located on the body. And not all part of the body, mostly the center part of the body. The reason for that is because if you have a closer look at the 3 images I showed before, if you look at the background is moving way too fast. So in the background, you don't have that much overlap. Because of the rotation you did between the shots, the background is moving much faster than the foreground. And you have virtually no possible matches because there is no similar visual content, because there is very little overlap in the background. In addition, in this image, you also have sky here on the top. If you look at the sky, there is no correlation that can be done in a meaningful way. So every part of the image that contains sky is useless information. So when we look back at this project, the part which contain 80% overlap is basically only the frontal part of my body, of the shirt here, and everything else has much less potential overlap, and it looks very different between the different pictures. Now, if you count the number of pixels of the body inside of this image, even if it was quite close, well, it's not a lot. It's maybe 30% of the whole image. And the number of matches you can achieve from such a dataset is much, much lower than number of matches you can achieve using Nadir datasets, unless you take the pictures slightly differently. But this big difference highlights a bit the complication, the more challenging parts which are happening when you are doing more oblique imagery than side imagery, than Nadir imagery. Another thing is, which is quite important to note, is when you have key points which are only in a selected part of datasets, well, then it's like if you're trying to position this image and you only hold it from one side, then the image has a lot more freedom to have imprecision, and if it has imprecision, then it's going to relate also in mistakes or more noise in the model. If you hold it, however, with your 2 fingers, with your 2 hands, meaning key points well put all over this piece of paper, then it's much more stable, and there's much less likelihood that there's a little bit of imprecision in the orientation or in the positioning of this image. So in this particular data set, you may got a bit more mistakes, a bit more error accumulation due to the fact that the key points are not well put all over the different places of this project. So what would be a solution to solve this type of issues? Well, I can give 2 large hints on things to do. One of the first one would be, as the challenge is between the background and the foreground, then if you put more than 30% of the pixels being the foreground, then you add the amount of positive matches you will have between the pictures. This would be shown in this picture. And this is usually done by going closer to the subject or using a zoom in your camera. Another way, which is often much more practical, is by using a fisheye camera. Like this, for example, would be a picture taken by a GoPro. With a fisheye camera, instead of focusing the whole of the key point attention on the center of the image, you're actually also capturing many different parts of the surrounding. And these different parts of the surrounding are extremely useful to help to have a nice spreading of key points all over the image, stabilizing better the image and getting more accuracy. So even if it sounds a bit unintuitive, fisheye lens help a lot into improving the accuracy when you are oblique and very close to the subject. Another way to do would be to actually reduce the distance between the foreground and the background. In this example there, instead of taking the picture 90 degrees straight of the subject, here we took the pictures from above. By taking them from above, my background is not anymore the horizon, it's not the infinite distance. It's actually a very close distance to the subject. What that means is that there will be also many key points that will be computed on the ground, and they will actually be helpful in the project, and they will help to stabilize the whole alignment and the whole calibration of the project. So these are different techniques for improving ground or oblique type of processing. That's another example about issues that you may have in an oblique dataset. Is if you took a picture in the traditional sense of taking pictures, then you usually will take a lot of sky in it. And as just mentioned before, sky does not have any key point information. And in such a picture, you will have a very large imbalance between key points which are in the bottom of the image and key points which will not be in the top of the image. And you may obtain inaccuracy in the alignment of this picture. One last subject about the difficulties of oblique imagery is even by changing your position very slightly in the space, you can have very different visual content in the pictures. So in this corner for the building, the human brain is very good at knowing that this is the building and I just moved a few meters around. But when you really look at the content on a pixel scale, you don't see anymore the same object, or they have such a different shape that the software will not be able to match them together. So when this type of things happen, it's basically you need to take many more pictures in between the two different pictures that we show there to help the software to do the transition, and not to have a picture where you see one side and another picture you see the other side, but really to slowly, gradually see the changes between the two sides. Now I'm going to go more into the topic, which is the topic of the webinar of today, which is really about merging data sets, one that would be Nadir data set, and the other one that potentially could be either an oblique or as well a ground data set. In this case, on the left, you have a picture taken from a copter from above, and then you have the same picture taken from the same location, exactly from the ground. And there is no visual match. It's the cars have, in one picture it's very big, in the other one it's very small. And in that case, the trunk of the car is totally black, but here it's not, just because it's been seen by a different view angle. And however, now we're going to also see how are the different possibilities to still have information from the ground and from the top put together in the same project. And there the question is really how to merge data sets which are both which have very different views, such as we just see in this slide. So really from the top and then from the side. The first method, which is the one that requires the less amount of manual work, but which puts a lot of constraints on how to take images, is to make a data set from Nadir. This would be a fully Nadir data set. And then to slowly take transition pictures between the full Nadir data set and the ground data set that you would see in this other set of pictures there. So basically, it's really to take images which do the transition, which have a lot of visual content which matches, between the two different set of pictures. For example, this is not possible to do with a fixed-wing drone, as you are limited in the pictures you can take. However, for example, with a copter, you could take a data set as a nice grid from the top, and then slowly take a lot of pictures that will make the transition into a different point of view. And then you could start doing the project from the other point of view and do a full reconstruction there. This transition is generally enough to make it able to calibrate two data sets at the same time. And then the only thing you have to do is basically put all the pictures together in the software and let the software do the processing. And you don't have to do any manual merging. The whole process is going to be automated. However, doing this transition is first not always possible. And it's also, in some cases, very, very challenging to make sure that there is sufficient number of pictures during this transition. So I'm going to talk much more about the second method, which is also useful to do which is potentially the one that we recommend when you need to do complicated project, when you need to merge very, very different point of view together. And basically, it's by using a set of manual tie points to guide the calibration. I'm just going to summarize right now the different steps of what's supposed to do, and then we're going to do a full live demo of different data sets where I'm really going to show step by step which are the buttons I'm choosing, clicking, which are the tie points I'm choosing to make this project work. So let's pretend we have two projects. The first one is a ground project, a project that I took using a ground camera. The first thing to do is to take all the images, put them in the software, and do the initial processing, the step one of the processing. Normally, you will obtain the whole model processed correctly, and then at that stage, the goal will be to identify and to mark 5 tie points. Once you have identified and marked these tie points, it's very important to click on the Re-Optimize button and to save the project. Then you can close this project. Then you do the same for the aerial project. You create a new project, you run the initial calibration, you identify the same 5 points that you identified from the ground pictures, and you keep the same name on these manual tie points. Also, not to forget to re-optimize the project and to save it. Once this is done, you create a new project by merging the two previous projects in a new one. The software is going to ask you if you want to merge the similar tie points together, where you have to press yes. And at that stage, you will already see the whole data sets which are nicely aligned with each other. Optionally, to increase the accuracy and to add more tie points, this is when you can click the Rematch and Optimize button, but we'll see that all with practical examples in a few minutes. For this data set, I'll present a project that with courtesy from Dragonfly, a UAV company from Canada, for which we collaborated in a project a few weeks ago. And in this data set I'm going to show you, you basically have 4 different data sets that were merged together. The first one is a Nadir set of pictures by a Sony camera using the Dragonfly copter. The second set is oblique imagery going around the building, still with the same Sony camera. Then I also took a Canon 5D camera and I took a bunch of pictures in front of the building. Finally, I took a GoPro camera and I went inside of the building to take pictures of the different rooms. And I'm now going to show you the different data sets. So this would be the front data set. So these are pictures taken by a Canon 5D camera from the ground. Very important when you take pictures from the ground is the importance of moving every time you take pictures. If you stay at the same location and change only the orientation, you are adding inaccuracy to the whole project. It's not very intuitive, but you are adding more mistakes by not moving in the data sets than actually moving 1 meter or so between each pictures. So it's quite important to always, whenever you press on the take pictures, to always be translating, moving the camera and not only doing a rotation. So as you can see here, I try to, when I have images in the foreground, like this car, which is closer to me, I have to take pictures in a much shorter range than when I only have pictures from the back. So if I take all these pictures and I create a Pix4D project, so just to give as an example, this is how I would do it. Open Pix4D Mapper, create a new project. This is oblique imagery, so I press oblique, front. I copy paste the images there. Next, it's not geotagged, which is all right. Then I would hit initial processing. I can disable the point cloud densification because I know that I will merge anyway the project together. So I can disable the point cloud densification and then just hit start processing. If I do so, I will obtain this result. This is not the full 3D resolution mesh. This is just the calibration point cloud. So you can see that the cameras were all nicely aligned and that a lot of key points were computed on the top of the building. If you see the imagery, you can see that most of the key points were on the building. In the sky, obviously, there were no key points computed. And in the front, the ground is so perpendicular to the image that you will have very little matches computed there. Then another data set would be, the Nadir pictures from above. So here I have a set with a very nice amount of overlap of pictures taken in a grid fashion, such as we usually do for Nadir projects and for normal aerial mapping. If you process this data set, you will obtain something like this one. So in this data set, there was the Nadir images, but I forgot also to show that there was already also a few oblique imagery too. And the reason why the whole thing merged nicely together is because mostly they are these transition pictures here on the right, which help the software to go from a full Nadir view to the same area with a bit of an angle, and then to this angle going from different position until reaching this second set of imagery. And this was done without any manual intervention. It was just putting the images in software, and that would be the results of automatic Nadir and oblique imagery merged together. However, I have another set of imagery that would be this one, where these images were taken extremely low altitude. So to merge, so this data set would be this one. So again, that's just putting the image in the software and waiting for the calibration to work. This is the results of the initial calibration. Finally, the last data set I'd like to show is the one of taking a GoPro and going inside of the building. So taking a lot of pictures. In this case, I didn't move enough. You should always move more between each shot. But basically, there you see this is really a GoPro Hero 3 going inside of a building. Because everything is so close by, you need to take the pictures very close by to for the whole calibration to work automatically. If you process this set of images that I just showed together, you would obtain this data set. So basically here you can see the front of the house that we just saw earlier, and then the pictures entering into the building, going a bit around and following the main corridor up to the back of the house. Okay, so now I have all these different data sets. So to summarize again, the one very close to the ground, the one which is both nadir and oblique, the one which is inside, and the one which is the front of the house. If I would put these 4 data sets together by merging them without doing anything, I can already tell you that it's not going to work. The differences between the point of view is so high, and there's very little overlap and very different little transition between these different data sets to work in a fully automated way. So this is where the Ray Cloud can definitely help you, and by inserting just a few tie points, you are able to really guide the software to tell it how to put the different data sets together, and not to make anybody wait to see the results. I'll directly show you a look on how the final results of all the data sets merged together looks like. So there you have the oblique and nadir, you have the very close to ground, you have the Canon 5D in a row here, which is even a bit lower, and then you have the let's make the image smaller, and then you have the inside of the I need to load the point cloud. You have the inside of the house, which was also mapped and reconstructed in the same model by merging these different cameras together. So how to achieve that? Let's follow the slide that I just showed before, and let's go step by step. So I would pick a first project. Maybe let's take this one. It doesn't matter which one, which of these 4 projects you start with. And in this project, the goal will be to mark 5 manual tie points that can probably be seen also from the other data sets. So for this project, potentially the one of the car is a good candidate, and potentially the top of one of the car is even better. So let's maximize this project. Here you have one of the car, and maybe let's select one of the corner of the car. By clicking on the point in the ray cloud on the corner of the car, you load the ray cloud interface that shows the pictures at different from all the different points of view for this data set. So what I'm going to create is a manual tie point. So I don't need to do any measurement in real life in this project. I can just click on new tie points, and I will mark a piece of the car which I know it will be easy to find also in the other data sets. So the box which is in the trunk of the car looks like a good candidate. So for that you need to click once. You identify it in another image. You click on apply. You can refine the measurement for more accuracy if you see that there are small misalignments in the green cross and in the real subject that we're trying to capture. So let's make one more here. One more here. I click apply, and there I just created my first manual tie point called MTP1. I will then repeat the same step for a minimum of 3 manual tie points. So we can do it from the other part of the car. Let's say that we do it from the antenna. That sounds something that can be easily spotted from the top. So again, I create a manual tie point. I click 1, twice at least. I check. All right, I can improve a bit by clicking here and here. Apply, done. That's my manual tie point called MTP2. Maybe on the door, that would be a good candidate too. This, I know it's not going to be visible from the top. However, I know that this dataset is going to be visible from the oblique, and that's enough. It doesn't need to be visible in every single of the 4 datasets I'm trying to merge. A point which is visible in already 2 will be already quite sufficient to do most of the merging. So again, I'm adding 2 points, checking that it's accurate. They're adding another one, apply. Okay, let's just start with 3. This should be fine enough. If you add more than 3, it's going to help a little bit to reduce mistakes that you may have done. Also important, where to place these tie points. The best is always to spread them as much as possible in your project. So it would be a mistake, or not a mistake, but it would be not very appropriate to do them all on the back of the truck. Because a small mistake there, or a small imprecision, may lead to large imprecision on the back of the reconstruction. So in that case, the tie point that you choose should be as well spread in the project to avoid inconsistencies between the different projects. Now I would select another project, maybe this one, and I would restart, I would redo my different manual tie points. So in that case, I already pre-clicked one, which is fine. And then I just need to annotate the other one that I also added in the previous project. Okay, so here you have the all right, there I just defined there. However, you have to make sure that in these 2 projects, the manual tie points which are defining the same object have the same name. So in that case, this one was called MTP2. So for this other project, I have to also call this one MTP2. Otherwise, they will not be recognized as being the same during the merging. Apply. Now, a very, very important step too. before you do the merging, you need to press on this button called Reoptimize. It's going to ask you something, press yes. What does this Reoptimize button do? It makes sure that the MTP that you just clicked on will be really put inside of the project file. And this is an essential step. If you don't do that, the project that you will try to merge will not merge properly together. So you really, before trying to merge your project together, make sure that for each of them, after inserting the manual type points, then you click on Reoptimize, and then that you save your project. If now I do modification to my manual type points, for some reason, oh, actually, this was not the one I clicked there, I need to move it or something there, I can do it, but then I have not to forget to repress on Reoptimize to make sure that the changes I did are propagated in the project. Okay, once I clicked Reoptimize in this one and save, and that I just do the same for this one. So I would also need to click on Reoptimize. Okay, let's do it. Or maybe let's first add the final type points so we can really merge these two projects together. So I have MTP1, which is not at the right spot. That's the right one. So that's MTP1. Apply to propagate the change. I have now MTP2, and I just need MTP3, which is at the front of the door, which would be this one. Okay, I need to rename it, MTP3, apply. Then I would click on Reoptimize. Yes. And now it's propagating the manual type points inside of the project files. As soon as this computation is finished, what I would do is I create a new P4D project. So I open Pix4D mapper, and I create a new project. This project is going to be a merge project. And instead of clicking on new project here, you have to select create a new project by merging existing projects. When you do so, then the software asks you to provide the two P4D file with your project that you just created there. So I'm just waiting for the processing to finish on this one. And I will already add the first project that is called front, which is located so that would be the first project in open, and then the second one, which is located DRCMP. Okay. When I press next, the software is analyzing the P4D files, the different project file, and now is asking me that the project have type points with the same labels. Do you want to treat them as identical? Then you have to press yes on this question. Then it just tells me that the project have different settings. I process them with different settings, but usually this is not an issue. Now, what the software is doing is that it takes one dataset, it takes these other datasets, and it's trying to find a way to put them together to be as close as possible to the type points that we identified by manually clicking on them. This is normally quite a quick process that should be quite soon finished. And we're going to put these two projects in the same coordinate system. So let's change a bit the visual properties to have a clearer view. Okay, and this is what just happened there. You have the ground data sets taken with the Canon camera and the aerial data sets taken both Nadir and Oblique with the Sony camera merged in the same project. Now, just to make sure that they are well aligned with each other, you can do a few manual quality control by clicking on a few points. And there, using the ray cloud on the right, you can make sure that the points are well aligned one with each other. So here looks pretty good. And later on, there will be the Sony camera. So the one called Imager are from the Sony camera, and the other one are from the Sony camera. I mean the Canon camera and the Sony. And you can see there's a small misalignment. Here I was clicking on the small doorbell of this door. So there is a bunch of pixels of misalignment between the two projects. The reason is because my tie points that I created right there are very localized to the front of the project. So a small misalignment in angle could have big consequences later on. So a good practice right now is to add a few more tie points in more spreaded part of the project to make sure that we correct for these small inconsistencies. If the images are very similar, then you have also an automatic way of doing that. And this is by clicking this button called Rematch and Optimize. What will happen if you click this button is that the software will use the new position of these two merged data sets to try to match locally, to find new matches between the images locally from all the different groups to put them together. And this will also enhance the calibration between the two sub-projects. Now, if you continue doing that for all the 4 data sets that I've been showing, you can either do one by one, putting them together, creating a merged one, and then add another one and add another one, or you could click the 3 to 5 tie points in all the data sets at beginning, and then merge the 4 data sets together. Both ways will probably give identical results. Once you have done so, you will obtain this data set. Maybe I can show you which tie points I've been using for this data set. So the tie points I use to merge the project together are a few one on the cars, also a few one on the front of the building, a bit also on the roof to increase the consistency between the different projects. And I've also added one at the back of the door to merge together the project that was done inside with the GoPro together with the one which was done outside with the UAV. And there you can see the difference in the size of the wall between the two. And the wall make a lot of sense that this is the right size of between the inside and the outside of this building. All right, so this is a bit the end of my presentation on how to merge different set of projects together. So now I'll be mostly answering questions from which were asked during the webinar. And so feel free to ask even more questions right now. So I will be able to take them one after the other. All right, so let's see a few questions. Can you demo taking a real-world measurements from within the model? Okay, this is quite an interesting question because it gives a bit of hint of how does the geotags propagate between the different projects. So in this project, there was only one of the four which had a geotag. All the other, for some reason, had absolutely no geotag inside of the project. Because my Canon camera didn't, my GoPro didn't, and when going very low, the flight log didn't record the proper GPS. So what's interesting is that it means that only the pictures here at the top have GPS position. However, since all the projects are now connected with each other, it gives the right dimension to basically all of the different projects, of all the different pictures within that project. And thanks to that, I'm able to basically go inside of the house, go in the conference room over here. Let's remove the camera just to make it easier. Okay, that's the conference room. And here we have magazine. And then I can measure the distance of this magazine, refine it in the image to make sure that we have a very, very accurate measurement done there. Click apply. And now this magazine will be computed to be 25 centimeter long, which seems pretty reasonable for that size of magazine. Between 25 and 29, depending how nicely I adjust the clicking. And this measurement, the scale of this measurement, was actually taken from the geotag that were on a fully other part of the project, and everything was nicely merged together. All right. So when shooting inside of a building, should we also move forward and not just pan the camera? That could be difficult to do inside of small rooms. Indeed, when you should always move the camera when taking the pictures and not panning around and not just rotating around. That's why we usually recommend to take fisheye camera. With a fisheye camera, you don't need to take the pictures up and down. You basically cover the whole room in one single shot. And the distance that you move between each pictures doesn't need to be very big. It can be actually just a few centimeters. When your room is quite small, this makes perfectly sense, and you can just take a few pictures there to reconstruct such an office. Of course, if I had taken pictures also from below the table, then you would be able to have more 3D information of below the table. But there I went quickly just on the beginning of the room. So a question about, is it feasible to take video camera stream to make this type of to take this as data for the capture, for the reconstruction? Yes, it's possible, but it's not recommended. You're losing a lot of accuracy by having such small images as Full HD, which is only 2 megapixel, or even 4K, which is just 4 megapixel. With the normal, if you even take the GoPro in still picture mode, you will have 12 megapixel images, and this makes quite a big difference in terms of accuracy and precision that you can get from a data set. Okay, a question: how do you obtain an automosaic of a side view? That's a very, very good question. Right now in Pix4D Mapper 1.2, you have to slightly tweak the system to make it happen. So basically, you have to create virtual ground control points on your roof, which pretend that they are actually looking top down. And by doing so, you can then generate the automosaic of your facade, because the software believes that this is the top-down view. In our support knowledge base, you can go in our support on our support website. We have a full article that shows step by steps how you would obtain, how could you obtain an automosaic of this facade. If we use the software on an indoor area only with our GPS, can we set measured GC point instead of scale to scale it accurately? Yes, perfectly. You can also, instead of doing the way we did there, you can also just shoot with a normal camera without any reference, and then you would create two virtual ground control points, one placed at 000 and one at 001, and this will scale the whole project from just a simple line measurement. Okay, a question about, does having more points on the background really help, since what I'm interested in the subject, not the background? This question is mostly related, again, to what I was showing at the beginning about the stability of the alignment. Indeed, what you need is the calibration on the subject. But if you only have key points on the subject, which is potentially my finger, then the camera can have misalignments in this and this direction. And this misalignment will propagate along the other images and starts producing areas with much more noise than if the whole camera was nicely aligned in each pictures. So, as you can see in the example, the 3D point clouds that I showed of myself was kind of good enough, but it would have been even better if the calibration, there would be key points better on the whole surface of the image and not just in the middle. How important is it to identify very precisely the manual tie points when I did the operation for the merging? That's a very good question too. It depends. You can do it not very accurately if you have a lot of them. So if you're going to anyway identify 50 manual tie points in your project, a little bit of inaccuracy in each of them is not too important, because since you have many of them, it will compensate for the mistakes you did everywhere. Now, if you want to minimize the number of tie points you're going to use, and usually you always want to do that because it's less work, you need to basically try to be as precise as possible, because every little mistake is going to propagate in the misalignment of the different projects. Okay, let's go in the other question. Okay, question: are you able? We add another layer. All right, a question. Could we add another layer? For example, a thermal layer over this type of model. This is a bit more generic question, but thermal imagery is usually extremely small and extremely noisy. So this is not something that can easily be processed in the same way that we are processing normal high-resolution RGB images. However, in the upcoming Pix4D Mapper version, we will have a way to merge datasets taken from very different sensors. If you know the distance and the relationship between the pictures taken by the RGB and the thermal, if everything is well synchronized. So this is a feature that we call camera rig, and this concept of being able to take multiple pictures if they are synchronized and well placed with respect to each other. We have many different modes where we can either just process one and use the other as additional layers, or process everything together to improve the whole accuracy. And this is one of the features that's going to come in Pix4D Mapper 1.3, which is due by the end of the year. I also have a few questions which are asked about the triangulated mesh. So indeed, this is also a very lightweight triangle mesh with texture. This is also one of the upcoming features for Pix4D Mapper 1.3, which will be released somewhere by the end of the year. Another question, can I make sure that the cameras of indoor are not processed together with the camera as outdoor? And yes, it's possible. So you can select to have different data, part of the big data sets to be processed then differently. For example, in this data set, I have 2 point clouds, one of the indoor and one of the outdoor only. The way I did that is before starting the processing, I went into the image properties editor and I manually selected a group for all the outdoor images, and then for the GoPro images that I took indoor, I choose them to be part of group 2. By being part of the group 2, when I start the processing, it will generate 2 different point clouds that I can easily switch from one to the other, and that to make sure also that we are not confusing the software by trying to take images from indoor and match them with outdoor areas. Again, a more interesting general question, is there a maximum number of images that can be used for a project? So normally not. We don't have a physical limitation inside of the software that will limit the number of images you can do. It's basically depending on the power, on how powerful is your computer, how big are the images, and also how much visual content in there is there in the images. There is possibilities to generate, to do a whole computation with, we've got customers doing several thousand of images together on a very powerful PCs. So you can easily do, easily with an extremely powerful PC, you can reach up, we've seen people reaching up 20,000 images processing together. But then usually it's, at that point, it starts to be more, makes more sense to take your 20,000 image data sets and to subdivide it into smaller projects that you can start processing individually, and then to start to merge them on only a later stage together. This is usually a better way to do the huge projects together. Okay, question, if I have to go closer to a facade because there's a tree in front, is it better to go first one way around the building and later take photos behind the trees, or what's the best way? I have to go closer to a facade. So let's find the facade. And the tree. So that would be exactly this situation there. We couldn't go very back. We had to be very, very close to the building because the facade was the trees were very close. So in that case, what we did is that when we had to go closer, we basically started to take pictures in a much more, to take even more pictures to make sure that the overlap would still be sufficient at that area. And as you can see, just in this angle, we were not able to, the density of point is lower because of the trees. We basically stopped taking pictures at that spot and we start moving in different directions. So being very close to the subject is usually nice because you can get high resolution, but it's much more difficult to ensure the constant overlap. So in that case, making sure that you try to take picture very close is I think the recommended way, but then doing another set of pictures further away from the facade would make sure that you didn't forget a small part of the facade like the user did in this case. So by having another layer of pictures from behind the tree, maybe it would have covered a little bit better there. But this is just mostly because of practical reasons, not because of theoretical reasons. How does the software understand the direction of the camera? GPS doesn't give camera direction. Indeed, the software is able to understand camera direction by just image analysis and by the relationship of multiple pictures, how they fit, how they are positioned together. So this is something the software is able to do automatically, but I think the best way to answer this question is to watch the first webinar about the introduction to photogrammetry. How did I remove the trees from this model? Okay, this model was actually much larger initially. There were quite a big areas there. What I used is I created a processing area and I set the software to not compute any points further than this area. The reason I did that is to speed up processing speed and also to ensure that I don't have points which I don't care about. So to do that, you basically go on the left panel and you create a new point cloud densification area. You click around the place where you want to limit the whole processing, so also the point cloud generation, and this will make sure that you don't have all the areas which are not the main subject of the reconstruction outside of it. Another way to do it, here you can see that there's still a little bit tree left in the data set. You can use the tool that we have here, which is the Edit Densified Point Cloud, which allow you to select a bunch of points you are not interested in. So let's take this one, press on the Delete button, and this will remove them automatically, and you can also clean up the model this way. Yeah, now I don't have any more trees in this data set. All right, well, we are reaching the end of this 1 hour webinar. So thank you very much, everybody, for participating and for asking questions and watching this webinar. And the support team will keep answering the few questions which are left unanswered. And with this, thank you very much again for watching this webinar. I hope you can take even more advantage of your Pix4D Mapper software. And see you in 2 weeks for the next webinar. Thank you very much. Have a very good day, and see you soon. Bye.